Hi everyone, my name is Rakshit and I work as a data scientist at Johnson Labs. Today I'll be walking you through one of our recent products, the medical terminology server. I'll start with a quick overview why it exists, what problem it solves in the real world scenarios. Then we'll explore its capabilities from both like a user perspective and the API perspective as well. So by the end of this session, you should have a clear picture of where the terminology server fits in the healthcare technology landscape and how it differs from the traditional NLP or LLM based approaches. So let's first start with what is the terminology server. So a terminology server is a specialized search engine for medical terminology. So think of it like a Google for medical codes, but much more intelligent. So instead of searching the whole internet, it can search across the official medical vocabularies like ICD, SNOMED, LOINC, RxNorm. But unlike the regular search tools, it doesn't just match the text literally. So it understands the meaning of the medical phrases, whether someone types heart attack or MI, which often relates to myocardial infarction. It can recognize all the point, like it can map to the same medical concept, whether it's MI or myocardial infarction. It converts the clinical text into the standardized medical codes. So it acts as a bridge between the free chunk and the structured codes that could be needed for analytics, billing, or research. So when someone enters a phrase like high blood sugar, so the server maps it to the correct vocabulary, or you can say it can also map to a OMOP standard concept, which is widely accepted across systems. So this conversion is crucial in healthcare because most systems don't understand the natural language. They need codes to operate consistently, and it's designed specifically for the healthcare data workflows. So unlike generic NLP or keyword-based search tools, TSA is built with real-world clinical usage in mind. It handles spelling mistakes, acronyms, shorthand, or sometimes even like patient-friendly language as well. So it allows the organization to set guardrails, for example, searching only within the drug codes or only retrieving the codes that are valid in OMOP or FIRE, which is like a standardized system. Yeah, so it's just a lookup tool. So but it's controlled, configurable engine, so it can fit directly into your coding environment. So now let's talk about why the terminology server was built. So the traditional coding tools rely on exact matches. Historically, like coding systems and HR would only retrieve a code if the user typed in the exact phrase found in the vocabulary list. For example, if the chunk says gastroesophageal reflux disease and the user types GERD, the older systems may not return any results for this. And this also creates some frustration, and it also slows down the work, and it often leads to incorrect or inconsistent coding. The clinical language is always messy. They have a lot of abbreviations, typos, variations. So, like the real world clinical documentation is far from standardized. Doctor write hypertension as HTN or high blood pressure as high BP. So, and they all mean the same thing. So patients describe sugar problems, diabetes, or high glucose. It's also a system that depends only on keyword matching. If a system that depends only on keyword matching will probably miss a large portion of these variations. So that's why the terminology server includes built-in synonym spelling corrections as well, and embedding based similarity search or semantic search. So it can understand the semantic meaning of the chunk with respect to TV. So it can interpret what human mean, not just what they type. It needs a smarter context aware search system. This is where the terminology server shines the most. So it doesn't just perform text lookup. It applies the clinical intelligence. It prioritizes the medical relevant matches, understand the concept relationships, and even restrict or bias result based on the context. We'll talk about it more in the upcoming slides. So it's more like only returning the drug codes when searching for a prescription workflow. It's built to mimic the decision making of a trained medical coder. So it's very much consistent with that. So it can recognize the context that you shared with them, and you can enter the chunk which is in the context. By context, I mean you can just in a sample sentence which contains the chunk, and it will recognize the context and have the semantic meaning of that particular chunk. So for the on-premise deployment, firstly, so it can run entirely inside your secure environment. So it's one of the advantages that it's just not like a cloud-based service. It can be fully installed on-premise. So that means all the data processing happens with your own infrastructure behind your firewall. So for hospitals or pharma companies or research institutions with strict requirements, this makes adoption far easier than the cloud-based services. So you can install the terminology server with one line command script with a license. So you'll need a license to install it. So the setup process is intentionally streamlined. So as long as the server has Ubuntu to 20 or higher and basic command line tools. So the script that it uses, let me show you. If you go here, you have the on-prem deployment installation guide. So like if you go to home or if you go to docs, then there will be a documentation for terminology server, and you can go to deploy on premise. So this is the command that you need to run, and you also need to have the license key from JSL in order to run it in your own local system. So the first setup may take some time due to downloading the vocabulary data. So it's like a huge database that we curated from our own personal data sets and some open source data that we got. So we have all the synonyms, most commonly used abbreviations. So but it's all completely automated, and you just have to just run the script and it will be ready in your system then. You can also refer to the documentation from the Johnson Labs website. The web UI and the API are available immediately after the setup. So once the installation is complete, the access is instant. So you can open the local host or your server's IP in browser, log in with the credential provided during the installation, and the full interface is ready from there. User can manually explore the terminology concepts via the UI, and the developers can connect programmatically through REST API. So no additional configuration is needed to begin searching. So you just have to run the command and it will be automatically configured in your system. The UI and the API will work as well after it's done installing. Let's talk about the key capabilities like in the high level overview. So it understands both exact and fuzzy clinical phrasing. So a user doesn't have to know the official medical term in order to retrieve the code. So whether someone types breathing difficulty or shortness of breath, TS can find the correct matching code by combining the keyword logic with the embedding based semantic understanding. So it can also find the exact match and the similar matches. With that, you can also define how many matches you need in your search results. So it supports multiple vocabularies in a single search. So instead of requiring users to pick ICD versus NOMAD, TS runs across all the available terminologies and let you decide how to group or filter the results. So maybe a clinician wants to see ICD first, while a researcher more care about the OMOP standard concepts only. So both the scenarios are supported. You can filter with as much vocabulary as you want. So it can also filter and constrain by the domain and the code system or the validity or the standard concept, like the TS gives like the organization control. So you can set rules that you only drug codes should appear when I'm searching in my workflow, or only the active codes should be returned when working with the standardized data sets. So we have a standard filter which will only give you the codes which are standard for OMOP or some other coding systems. The vocabularies and the concept map feature. So we have all the major vocabularies. If you see here, we have all, I think, 16 vocabularies. So you will get all the standardized vocabulary that are widely acceptable. So we have feature which is concept mapping. So like a single medical code from a source system may be mapped to one or more codes across multiple target system. And so like it's like a curated concept maps, and it shows the exact match from the source system to the target system, and the relationship between the different coding systems. So it's like a pre-built dictionary, and it's maintained by us. So it's just not like guesses. They are all rule based. So if you provide a source code for ICD-10 like E11, and then you can select which target system you need. So by default, it will search through all the target systems. So if you want to filter them out, you can also choose the target system. So particularly, these mappings are vital when you are consolidating records from different healthcare systems or migrating the EHRs. So it depends on the user's use case. And we have a UI that lets you see how the concept translates across vocabularies in real time. So let's talk about the search capabilities of the terminology server. So either you can enter a medical code and retrieve its equivalent concepts, or you can enter a particular chunk and retrieve its particular code. And so this feature is called the code search. So it lets user to enter a specific code, like for E11, ICD-10, or type 2 diabetes. The terminology server returns the code's equivalent or related entries in the other code systems. For example, from E11, you can get matching concepts from the vocabularies that you select. You can also search with the clinical phrases using both exact match and the semantic search. So this is the main thing that we usually use in our products. So we are already using this TS in our internal projects. So if you enter any chunk like high blood sugar, so, or imagine a spelling mistake like in diabetes, you have entered, you missed some alphabet between them. So, but the terminology server still knows what you mean. So it uses two types of matching: exact string and semantic embedding search. So the embedding model captures the meaning. So even if the wording is imprecise, the server will find the clinical appropriate codes. And the search results are deterministic, meaning you will get the same matches consistently every time for the same input, which is important for in clinical workflows. We also have Boolean logic, so like a clinical domain filters and the context tags to narrow down or like prioritize the search results. So our search engine offers some advanced tools to tailor your results to your exact needs. You can use the operators like and or in your search. For example, lung and cancer, or stroke or TIA. You can filter by the clinical domain. For example, limit the results to just diagnosis, procedures, or medication. And here the context tags helps too. So if you mark a search as coming from a medication record, the terminology server will boost drug codes in its ranking. So these features ensure that the results are not only accurate, but it's relevant to the task in hand. So in short, if you search for a search using the cancer or lung or cancer and lung, it will give you the codes related to both of them, whichever operator that you use. Now comes the custom uploading the custom value sets or domain specific filtering. So you can upload your custom list of codes grouped by a clinical theme, task, or a specialty. A value set is essentially named collection of medical codes, a curated playlist. For example, you could create a value set called breast cancer diagnosis and include ICD-10, SNOMED, or mesh codes that relate to that particular topic. Or you might have like cardiology medications, for example, set made for only the RX norm. These sets can be created manually in the terminal server. You can upload a CSV or Excel. We have a format for the value sets, which I'll show. They are perfect for understanding the workflows, building the rule sets, or supporting the phenotype definitions in the research. So we use our value sets as filters to restrict the search results to relevant concepts only. So once you successfully uploaded the value sets, it will be like a part of your search environment when it's active. It will highlight or include all the results that match the codes from your selected value sets. Let's say you search for chemotherapy and you have some oncology specific value set turned on. So your results will be limited to the codes in that value set. So it removes the noise and the irrelevant matches. So it makes it easier to ensure the clinical relevance. You can also track the versions and the changes to the value sets over time. You can check which value set has which version. So you can also update it. It will have a version 2 of it. It just means that you can update them and keep track of your changes. So this is mostly required in large teams or like regulated environments. If you are doing a study which uses version, for example, 1.3 of value sets and someone later updates it to 1.4. So both versions are still available. You can trace what was changed. This ensures full transparency between the people. Let's now talk about the terminologies versus the OpenAI LLMs. So that the terminology server delivers deterministic code-backed outputs, whereas the LLMs generate variable responses without guaranteed terminology accuracy. This is one of the biggest philosophical differences between these two approaches. TS works like a validated lookup engine. If you enter a term today or next year, you will receive the same standard code because it relies strictly on the official terminology database. Like the code can change if the validated database has some changes in the codes like Athena. So we usually keep it up to date. So like the LLMs like GPT on the other hand generate free-form responses. Even with the same input, they may return slightly different code on different runs, and they have no direct access to structured or up-to-date medical terminologies like ICD or SNOMED, unless explicitly provided in the context. The TS offers fixed licensing, on-prem deployment, and full privacy control, and LLMs are cloud only and metered per usage. So TS can be deployed entirely on your system, making it suitable for healthcare environments. The cost of the model is stable regardless of how many lookups are performed. So even if you send 1,000 chunks or 1 million chunks, the cost will remain the same. Whereas with LLMs, every request incurs usage cost and all the inferences happen in the vendor's cloud environment, which introduces both financial unpredictability and the compliance barriers. TS also provides the UI. It has the UI and the API support with various features, as we already talked. Whereas the LLM offer only the API access with no terminology model backed from behind. TS is designed specifically for terminology exploration, so it gives user graphical interface to browse, inspect mappings, filter. LLMs do not natively understand the code systems or hierarchies. They only respond to free text instructions. So any terminology control must be manually enforced either via prompt engineering or connecting it to external system, which can be a hassle sometimes. TS excels at like precise term level mapping, whereas the LLM excel at the document level inference and abstraction. This is where the two tools complement each other. So TS is the right choice when you need to map a single term or a phrase to an exact code. It does not try to interpret a broader context on purpose, but we can still do it with our context-based searches, which I'll show you. The LLM thrive when you provide full clinical notes. They can infer likely diagnosis, procedure, or medication, even if it's not explicitly stated. However, that abstraction comes with variability and reduced explainability. TS stays continuously aligned with the official vocabulary updates. The LLM knowledge is static and may lag behind. TS database actively syncs with verified coding systems and distributions, and it reflects the latest terminology revision. So we keep on updating it when we have some changes in the codes, or some codes are depreciated, or some codes are not valid now. We keep our DB up to date. LLMs, on the other hand, are trained on frozen data sets and may not recognize newly introduced codes or the depreciated terms unless it's fine-tuned or manually corrected. This is the comparison with TS with respect to using the LLMs. Let's now go to the UI. I can walk you through how to use the UI effectively. If you want to see the documentation, you will need to go to the Johnson Labs website, and you need to go to the docs section, then the terminology server, and you'll find all the documentation, what all features that we have here. We have the installation guide, on-prem installation guide. You'll need a license for this, and you need to run this command in order to have the TS right in your machine. There are some recommended configurations that we have. So you need the Ubuntu 20 plus machine, and the TS service uses port 80. It expects the port to be unused. The minimal configuration is 16 GB RAM and 8 core CPU and 300 plus GB storage. If you have a bigger machine, the responses will be much faster. If you want to process millions of chunks in bulk, the ideal configuration would be 32 gigs of RAM and 16 core GPUs for decent performance. But again, you can always upgrade from this as well. It can open on Apple Safari browser, the UI, Mozilla Firefox, and Google Chrome. We also have the API service access and the API documentation on how to use the API. We also have a notebook for that. I'll walk you through. We also publish our release notes here. Like this version, current version is V3. So you can see all the changes that are included in V3, what all things have been changed. Now to go to the terminology server UI. So we have one demo server running. Right now, you won't see this because we'll need to add you to the approved user. I'll just log out from here. So you'll see this page open up, and we will have to write our credentials here. If you need to test it, you need to get in contact with our team, and we can create a new user for you in order to access this URL and in order to use it. I can also create user. Let me just log in. admin. I can create and manage users from here. So right now, we have 3 users, and I can create a user for someone who needs to use this service in order to test it. So we can provide you with the credentials. Now let's go to the main UI section, which is the search feature. So let's first talk about the code to code mapping. So it means that you can map from one code to another code in different vocabularies. For example, if we enter, let's say E11 here, and we will get all the results. To have the code to code mapping, which is hopping from one vocabulary to another, you will need to select the concept maps. The code system are the filters that we use in order to get the data output. So for the code to code mapping, so the concept maps are used. So the concept maps means like E11 is from, for example, ICD-10, and we want to map it to ICD-9, Mediare, PD or LLD or SNOMED. So you need to click the map codes here first, enter it again. So you'll see the source code system, which is ICD-10, and it's also ICD-10 CM. So this E11 maps to Med, TRA, PT, or LLT, and the UMLS. So if you want that this code source system is ICD-10, and you need the UMLS mapping or the mid-TRA mapping, you can just select this from here. So if, for example, E11, I want to map it to my DRLLT, I'll just click the search, and you will end up with the source code and the target code system and the target code value. So this code maps the coding system ICD-10 to this code in the target code system at DRLLT. So this is how the mapping of the codes happen in terminology service. Then comes, functionality. Let me just uncheck this. If it's all unchecked, you will have this search bar, which can do exact match search or the semantic search. So if we enter here diabetes, it will give us exact matches first. So the concept name, diabetes, and you will see the things related to diabetes from all of the vocabularies. So it will have the results related to the diabetes chunk. And if you want to filter it by certain vocab, so you need to go to the code systems. The code systems are all the vocabularies that we provide. It also has some home vocabs. And if you want to only see the SNOMED code, SNOMED results for the diabetes chunk, we can just click the filter. You can also add multiple filters. For example, if we want to search with Loink, we'll just add those filters, and then we'll end up with those results only. So if you see here, this is the Loink code, and it will have all the metadata regarding it, like the concept code, validity, standard concept, chunk, domain. So for example, this is the hierarchy tree. So we need to find which one has the hierarchy. Okay, so similar to this. So this one will be the parent concept, and these are all the child node for the particular chunk. So the hierarchy is more like, for example, diabetes mellitus. It can refer to so think of it as a parent chunk, and it can also have the child chunks as type 1 diabetes, type 2 diabetes, and that's how the hierarchy is decided. So you can also see like which one is this? Diabetic education procedure. And you can, if you want to see this code, what it means, you can just click it. So you'll see the code procedure here. And the previous code was also diabetic procedure. So it's just a child class of it. So this is also one another functionality, like you can also search the code here directly. If you search E11, it will get the E11 results. So let me show you. It's selected line. We need to uncheck this. It's ICD code. Okay, yeah. So you see here the ICD-10 coding system or ICD-10CM. So it has the E11 concept code. So you can also search via this. So this is the search functionalities, and let me just enter it again. Weeklies, you can filter it by, we have all these filters. If you want just the exact search, you can just click the filter here and search on it, and it will only result with the exact matches. And if you want all the matches, you can click the semantic search. It will have all the semantic searches. And the default search here means that you will get the both exact match and the similarity search. So it first will be the exact matches followed by the similarity search. You can also filter it by various other things like domain is condition, drug. We have all these domain IDs in our system. And if you want to just include the standard concepts, you can just check that and you'll end up with the standard concepts only. And if you want to like get only those columns which you need, you can do it from the column section. Like if you do not need the concept name, or if you don't need the validity, or if you do not need the standard concept, you can just filter this out and save your changes. And you can also download it. You can check all and then just download from here. You'll end up with a CSV of your own. So this feature, the context resolution feature, is like a context-based search. So it is ideal for clinicians or coders or researchers who need to retrieve highly specific coding information, like tailored to their specific healthcare scenarios. So it narrows down the search results by filtering them by term weight. Term weight will be the weight of the chunk, and the scope will be the number of words we are taking, like from the left of the chunk and the right of the chunk. So, and then we calculate a weighted average embedding between the scope and the sentence, and we get the output. So let me think of a sentence. The patient has hypertension and complains about headache. So if I want to search the code for hypertension, the search API that we had will probably give all the exact matches and all the similarity search for the code hypertension. But if you search hypertension here, and you can choose the chunk term weight according to you. You can also set the scope to 4. For scope 4 means it will take 4 words from the right and from the left. So it will have all the context. And let me clear out the filters. So if you see here, we just searched hypertension, but it also gave us headache, which is in the context. So this is how we use the context resolution. So You can use the higher term weight when you're confident in your terminology, or use the lower term weights when the context is critical there. So you can adjust the scope based on how much surrounding text you need to affect its meaning. So, and you can also always combine it with vocabulary filters and all these filters to narrow down the search results more. So instead of relying solely on the keyword or the phrase entered, so this feature enables us to specify the additional informations uh, uh, like these filters as well with respect to the context resolution. So like it's a powerful feature uh, that sometimes enhances the accuracy of the relevance of the search results by allowing the users to include additional context when searching for medical terms. So this is also one feature that we have. Now let's talk about what was the Boolean search. So the Boolean search just uses and or operator between the queries. You can enter diabetes or lung cancer. So the results will have the diabetes codes. Ah, okay, so we need to clean this up. The interest moment. Hmm. Oh, it's or. So for or, yeah, you'll get the results for like one of them. So it can either give the diabetic result or the lung cancer result. So you need to choose the operator according to your use case. Right now, this only gives us top 20, but in the API, you can get as many as you want. For example, if we have here the diabetes and the lung cancer, it will give the results regarding the lung diabetes. If you see here, it has lungs or diabetes results in the output. Mm, at risk of diabetes, lung cancer. So this is one more feature, which is the Boolean search. And then we have the spell checker feature. I think you already saw it before it popped up. Uh, how it works is like if we enter mm, a typo like hypertension. So this chunk is wrong. So our TS should probably give us the suggestion for it. It says, do you mean hypertension? If yes, you can just click on yes and it will search the correct one. So right now, if you see the results are bad here, but if you just click the hypertension as yes, you will see the search results being changed. So if you see here, the concept name now is the hypertension, which is correct. So this is how we filter by, this is how we correct our spelling. So it will probably pop up when you will have like abbreviations. So let's try one abbreviation T2DM, type 2 diabetes mellitus. And it will, mm, so here, if you see, we just entered the T2DM, which is an abbreviation, and we got the concept name for it and the concept code. So it can also work with abbreviation or let's say difficulty in breathing. So the difficulty in breathing gives us breathing difficulty, all these concepts, and you can always filter it by the vocab. So you'll get the ICD-10 CN code. And if you just want to see it as a condition, you can just have the condition domain filter on and search it. So the domain will always be condition. So you'll get all the results of difficulty in breathing and the domain condition in the code system as ICD-10 CM. So this is for the search functionality. Then comes the value set filters. So you'll have to upload your value sets from your system. I already have one here. I uploaded it. So this is just a dummy one to show you. The data might not be correct as well, but we have the domain, the custom code, the custom term, the alias name, the standard code for it, and the standard term. So for example, if we search this particular chunk, so we get type 1 diabetes as an output, and then we can filter it by the value sets. Do I have some filters? So let's remove this. You can click it from here. This is the version 1. You can also upload more versions to it. And when you just click the value set feature and click on search, so by default, you will see all the similarity search results or the exactness search results with the value set column here. So if you see the ICD-10 for type 1 diabetes mellitus E11, we have the custom code. Oh, I mistakenly clicked it. Let me do it again. Yep. So for the value sets, if you see it's E10, you can also view the value sets from here. So E10 is this term, and we have the custom alias name as T1DM, type 1 diabetes mellitus. You can see the custom code, which you can use, the custom system. You can also have it in the CSV, the preferred term alias, and the standard code and the standard term. So if you want to just see the value sets results, you will need to go to the filters again, and you'll have to click this filter by value set to just include the value set results in the output. After clicking it, you can hit on the search and you'll get this result here. So let's try with something else, like this one. So you can also enter multiple in the UI as well. So here we end up with all the value set codes for that particular concept code. So this is how the value sets work, and you can also share it with the user. So for example, this is the version 1, and you want to share it with some other user which is using the terminology server. You can add it here, or you can share it with all the users. You can enter the name, email, and confirm. So it will be available in their system as well. So it's useful for the research purposes there. So this is pretty much about the UI functionality. We also have the API service access. So you will need to get the access token. or the username or password to generate the access token. So it's similar to how I generate the users for it. So after I generate the user, you will get a username, password, and you can just enter it here, and the API will work in your local system. Now let's go to the API. So the notebook is in the Spark NLP workshop inside the certification training notebooks, and the terminology server API. Let's open it in Collab. So you'll need the base URL as the terminology .demo.johnson.labs.dev. So this is our demo server running, and you will need to have the access token. To get the access token, you'll need to have the username and password here. And this notebook has the same things which I mentioned in the UI. So it has code mappings, which is like if you want to have the code maps, you can enter the source code E11, E14, and run it. You'll get all the mappings. This is the API output that we get. You can specify the source code, the source vocabulary here as well. And you can also have the target vocabulary as mid-array or something else, whichever you want. And it will give you the same output like we get in the UI. So for the term to code mapping, we have this search functionality, which is same as in the UI. You will have all these features, and you can also take the how many results that you want for that particular chunk. So you can just search diabetes and run it, or you can also have some features like the filters like standard concept. Okay. So you'll end up with all the standard codes. You see the codes are standard. You'll see two coding systems, source Athena, and sometimes you'll see the source as JSL. So it is coming from our own resolver datasets, which are curated. It has synonyms, abbreviations, etc. So these are the two sources where we get the data from. So one is Athena and the other is our resolver datasets. And similar to this, you can use all the things which I mentioned in the UI in the same way. You can refer to this notebook as well. We have all the features that I just talked about. It's just a simple API call. You have all the filters already in this notebook. So it's just doing the same thing, but with API. And you can always pass in a list of chunks in the query, like diabetes or lung cancer. You just have cop k is equal to 1. So it will give us the output diabetes or lung cancer. So you can refer to this notebook if you want to see the API usage, and that's pretty much about it. So that brings us to the end of the session. Thank you for your time, and I hope this gave you a clear picture how the terminology server fits into the real world workflows. So thanks again, and have a great day.